Hey guys, welcome back to Tronics Energy. So today we have done a JK flip-flop, and this is how a JK flip-flop integrated circuit looks like, and this is how it operates. We are going to go deeper. We are going to make it using individual logic gates. So this is the individual logic gates of the JK flip-flop. So these are exactly the same circuits, only that these we're using individual logic gates. For this one, it has an integrated circuit, so that's why it has compressed all this into one circuit. So this is basically how a JK flip-flop operates. It has the input section where we have the clock. Any 555 oscillator mode, you can use a multi-vibrator. If you don't have any 555, we have the input J and K, and the outputs enter this logic gate, this IC, which gives the output Q and Q bar. So when I turn the J on, it's going to turn on this green LED, showing us that we are feeding data to our circuit like that, and it's still going to remain on even if I turn it off until I press the K, and it's going to turn on to the other side. So that's basically what we're going to do, so please enjoy. Yes, so for us to make a JK flip-flop, using this application, you require the components shown. There are better ways to make JK flip-flop. You don't require all these logic gates. Like for the input section, we just require 3 input NAND gate. Since this application doesn't have, I'm going to use AND gates and NAND gates to do that connection. So yes, so basically these are the components that I'm going to use, and I'm going to explain how the things are operating. So let's start. So the first switch, I've called it switch J, and the other switch I've called it switch K. And yes, so let's start connection. So switch J, I connect its output to the input of the first AND gate. Then the other input we connect it to this 0.5 has signal generator. The signal generator, I'm using it as a clock. We are going to use on the breadboard, you're going to use an NE555, but if you don't have NE555, you can still use a multi-vibrator, which is going to work just the same. We do the same to this AND gate, switch K. We connect it to its input. Then the other input, we connect the signal generator or the clock. We're going to call it clock. Yes. So the output of those, the output of those AND gates, we connect it to these inputs of these NAND gates. So the output of AND gate 8, we connect it to that input of NAND gate number 2. The same goes to this. We're going to connect it to NAND gate number 1. And yeah, we're moving on. The output of this NAND gate number 2, we connect it to the input. So the other input of this NAND gate, we are going to take it from NAND gate 6. And the other input of this NAND gate 1, we are going to take it from NAND gate 5 at the finish, when we finish. So that we are going to leave. So by now we are good. So at now we're going to leave them like that. We are going to finish the connection when we are done. So NAND gate number 2, we connect its output to input of NAND gate number 5. Let me connect it to this other, yeah, like that. Then the output of NAND gate number 1, we connect it to the input of NAND gate number 6, like that. The other inputs of this NAND gate number 6 and 5, we interconnect their output. So for example, NAND gate number 5, we connect it to the input of NAND gate number 6, like that. Then output of NAND gate number 6, we connect it to input of NAND gate number 5, like that. Now we are done. we just connect our LEDs. So for this first one, we are going to connect blue, and for this one, we are going to connect green. Yes, green. Yeah, yeah, that's that. Okay, so we want to finish our connection. Let me make this then right. Connect that again. Connect that again. So I'm just doing the same as I did, and then this output, we interconnect them together like that. So this output, we're going to connect it to, let's connect it to green, and this output we connect it to blue like that. I wanted the blue to be at the bottom and not at the top side. The top side we are going to use green when we are feeding data to our circuit. Then we finish off our connection. The output of NAND gate number 6, we connect it to the input of NAND gate number 2, this NAND gate number 2. So the output of this NAND gate, we jump it off to that section. Then the output of NAND gate number 5, we connect it to the input of NAND gate number 1, like that. And just like that, you've just made a JK flip-flop. Then let's switch and test it out and see and understand what it does. So when I switch on this switch J, when it aligns with the clock, or when I switch it on and it aligns, or when I switch it on and the clock is high, it's going to give a 1 output in this AND gate. The AND gate will give a 1 output. When it gives a 1 output, it's not going to change anything. Oh yes, it's going to turn off NAND gate number 2, because the operation of a NAND gate, when both inputs are on, it's going to give you a 1, it's going to give you a 0 output. So since it's on now, when we turn on the other input, which is coming from this AND gate, it's going to turn off this the input that it's feeding to this NAND gate. Once it turns it off, it's going to turn on, because this is turned off because both the inputs are on. So that's why it's 0. So that's why this LED is not lighting up, since both inputs of this NAND gates are on. And when both inputs are on for a NAND gate, it gives you a 0 output. So once this is turned off, it's going to turn this on, enable it, then this will be turned on. Green LED will be turned on. So let's check and see. So when I switch it on and it aligns with the clock, it shifts and turns on the green LED. It enables NAND gate number 5 to be on, turning on the LED right there. So that means that we have fed data to our circuit, and it stores the data. Even if I switch the switch off, nothing is going to happen, since when I switch it off, the AND gate is still going to give a 0 output. It's going to give a 0 output. That 0 output at AND gate number 2 is not going to do anything much. It's still going to give you a 1 output, because one of its input is 0, which is coming from NAND gate number 6, because we have turned off NAND gate number 6. So meaning that NAND gate number 2 is still going to be on, meaning that it's still going to enable NAND gate number 5 to be on, then lighten up this LED. So nothing will happen. Even if I switch this on and off, nothing is going to happen. When I switch the K, when I switch the K in the K switch on, and it aligns with the clock, then it means that it's going to enable AND gate number 7 to be on. When AND gate number 7 is going to be on, it's going to enter this NAND gate number 1, and since NAND gate number 1, the other input is on, when AND gate number 7 is going to be on, those both inputs are going to make the output of this NAND gate to be 0. Once this NAND gate is going to give 0, it's going to enable NAND gate number 6 because one of its input will be 0, enabling this LED to be on. Once this is on, it immediately gives that feedback to NAND gate number 5, and when both inputs are on, it's going to give you an off signal, which is going to turn this green LED off. So it's going to turn this off and it's going to turn the blue LED on. So let's switch and check what we mean. So I turn it on, and when it aligns with the clock, it gives the blue LED. It enables the blue LED to be on, meaning that we have reset. We can call it reset. Yeah, you can call it reset. So that's basically how JK flip-flop works. The difference between this, you can know that this is pretty much it's almost the same as the D latch circuit, but the difference between this and the D latch circuit is that this has two inputs. You can remember that the D latch circuit had only one input called the D, and the other input was the clock. So for this one has two inputs, J and K, and the clock. So yeah, so that's basically what this circuit is. So let's go straight away to our breadboard and check how we can connect that circuit. I'm going to show you how to connect it both using individual logic gates and using a CD4027, which is a dual JK flip-flop integrated circuit. So let's go straight away and see what we mean. So yes guys, this is the real deal. This is the demonstration now of the JK flip-flop. I hope you've understood the simulation and how the components communicate with each other and how they are connected together. It's going to really help you understand how to make it on a breadboard and different ways of making it on a breadboard. So here we have this section right here is the clock. You can see the LED turning on and off. It's the clock of the that's going to be used at the input section of those NAND gates. And right here we have the switch. It's a deep switch. I'm using these two fast switches. The first one is J, the other one is K. Then here we have the circuit that is controlling the LED. So the first one is a AND gate, the middle one is a NOT gate, and the last one is another AND gate. So I'm using two AND gate IC because the first one is used. I'm using all of the AND gates because these are two input AND gates. I'm making them to be three input. Then I negate that output. I invert that output at this NOT gate to make them to be a NAND gate. Then the output of the final NAND gate enters this AND gate. Then we invert that output back to NAND gates because our circuit, if you can remember, we've just made it using NAND gates only. There's a way in which you can use AND gate and OR gate. Maybe we'll do that next time, but for today we have made it using the NAND gates. So that's basically the circuit. This LED we're going to call it J, and this other LED we're going to call it Q, and this is going to be Q bar. So this Q is going to show us when we are feeding data, and this is going to show us when we are resetting. So it was on already. Let me turn it off. Yeah, this resistance, no, yeah, like that. that. Okay, now this is the initial state where we say that the circuit is in a normal state. I don't know why this is not holding up very nicely. Let me change that pin like that. So this we can call it this the normal state of the circuit. And when we turn on our J input, we expect that the Q to be on, meaning that we are feeding data to our circuit. So once I turn it off, when you turn it on, and when it aligns with the clock, it must align with the clock. If I turn it on when the clock is 0, it's not going to do anything until the clock turns on again. So let me show you. We can time when the clock is off, then we turn it off on like that. Then when it aligns with the clock is when the green LED will be on. So the green LED shows us that we have fed data to our circuit, and nothing happens even if I turn the switch off. The circuit still remains at that state because how I explained it in the simulation, if you understood it. Yes, so the only way to reverse this or to change the state is to press the K switch like that. When it aligns the clock, it gives a 1 output at the Q bar, meaning that we have reset our data. So that's basically how the JK flip-flop works. And difference between this, I explained difference between this and the D latch circuit is that this has two inputs, the J and the K. The other D latch had only D or the data. So this has two, as the J and the K and clock. So that gives you 3 inputs. So let me turn it off and let me show you how an IC. This is an IC. This is the CD4027. It's a dual JK flip-flop integrated circuit. Has 2 JK flip-flops. Yes. So let me show you how it operates. Still the same, but this is much better. You can see it. It's much better than having all these integrated circuits. So it still works the same. Let me turn it off. That, yeah, like that. So it still works the same. When I turn the J this switch on, it's going to turn on the green LED. So when I turn it turns on the green LED, meaning that we are feeding data. And when I turn it off, nothing happens until I press the K input. Is when it's going to turn the blue LED on, like that. So that basically how JK flip-flops work. Yes, so next time we are going to do something else, and we are going to move on from there. Thank you very much guys for watching. Please subscribe to Tronic Energy, where we do fun stuff all day, all time.